Hello, am I audible? Okay, once again, I will just present my screen. Hopefully, my screen is visible. My screen is visible or not? Hello? Okay, perfect. That's one thing. So, hello everyone. My name is Sreyash. I'm going to take your today's session on IoT. So let's start. And yeah, let's make this session more interactive by asking question. Like, if you have any doubts in between the session, you can ask like anytime. Okay. So let us take a quick recall on what we learned last time. So basically, what is IoT? So IoT stands for Internet of Things. So basically, it is a system like all the devices and sensor like which are connected to the internet can be accessed through this internet. So there is general definition of IoT is given. Like IoT refers to the network of physical objects or things which is embedded with the sensors and softwares or if with other technologies that enable them to connect to the internet. Using that, we can exchange data or can control the devices through the internet. So as you know, nowadays, most of the vehicles like home appliances and other devices are connected to the internet. And there are some microcontroller available in the market which are used to interact, like to interface those devices or sensors to the internet. With the use of this Internet of Things, we can either collect data or we can also extend data over the cloud. Then why IoT? So Internet of Things has the ability to connect various devices and automate tasks. So you can not either only collect data or transfer data, but you can also automate the task. Right? So if there are some advantages of IoT, which is like it is efficient, convenience, and it has like security. Well, it has high security. So there is some examples are given like smart homes, wearable technology, like then transportation, healthcare, agriculture, and industrial automation. These are some applications of IoT. So this is a block diagram given, like how IoT works. So in the first, you can see there are sensors. So this sensor is connected to the microcontroller through which the data is transferred by a gateway to this cloud server and then to the app which is installed in your mobile phone. We can like the cloud server act as a communication network between the mobile phone and sensors. So there are so many components of in IoT. There are these are some basic sensors. So as you can see, there is an ultrasonic sensor which is used to detect the uh, distance between the object and the sensor. Then there is a gas sensor, color sensor, PIR sensor, and a lot more sensor. Like this sensor can measure different physical quantities such as temperature, pressure, humidity, motion, light, and sound. So generally, these are the basic sensors which are available in the markets. There are also some different sensors which can detect other physical quantities as well. Yeah, so to use those particular sensors, we need some microcontrollers which can uh, which can get the input from that particular sensor and give us the output. So these are some basic microcontrollers. So some of them are Arduino ID. like Arduino Nano, Arduino Uno. Then there is ESP32, which is a Wi-Fi connect, which has a Wi-Fi inbuilt. So the most common microcontroller available in market is like Arduino Nano, then Arduino Uno, then Node MCU, which is ESP8266 and ESP32. So in this ESP8266 and ESP32 can has an inbuilt Wi-Fi, but not in Arduino Uno and Nano. So these are some gateways which are used to for the communication between uh, IoT devices. So there are first we will see the wireless technologies and then the IoT network protocols. So there are some IoT like various wireless technologies such as Wi-Fi, Bluetooth, Zigbee, LoRaWAN, and NB-IoT. So these are the technologies using which we can communicate between two devices without any protocol or like any IoT protocol. So if two devices are connected in same Wi-Fi, for example, so we can communicate using the Wi-Fi, or you can say like if a device is connected to the through the Bluetooth network, you can also communicate through that also. Then there are various IoT network protocols such as MQTT, HTTP, LoRaWAN, and Zigbee. Using these IoT protocols, we can communicate between IoT devices in long range without initial through the cloud server. Then, then here is one of the most famous or easy cloud server, which is called ThingSpeak. This ThingSpeak is common is a it is an open source IoT platform which is commonly used to store data, then data processing and visualization. We'll see further like what is the use of ThingSpeak and how we use that. Yeah, these are some of the applications of IoT, like smart homes, wearables, smart city for smart cities, grading, etc. So nowadays, IoT is mostly used in smart home appliances only, and then for wearables such as your smartwatch, smartband, etc. So yeah, so our today's main topic is introduction to Arduino IDE. So the question is like, what is Arduino IDE? So Arduino IDE is an open source software. Uh, Hello. Okay, here is I guess a question. What is a flex sensor? So okay, did you mean flex sensor? Hello. Hello. So Jay, did you mean flex sensor? Hmm. Yeah, let's get back to the introduction to Arduino IDE. So Arduino IDE is an open source software which is used to write and upload code to the Arduino boards. There are some common Arduino boards such as Arduino Nano, Arduino Uno, and Arduino Mega, uh, which are the microcontroller boards and which are commonly used to interface with the sensors. Okay. Yeah, okay. He's asking about the flex sensor. Now, so flex sensor is nothing but like uh, it is sensor like which is used to measure the amount of what we can say the deflection or bending. Like it is a thin sensor. It as you can see like it is thin strip. If you bend that particular strip, the amount of flexible or the amount of deflection it is getting, it will give that particular value to you. Hello. So basically, like if assume like I had a paper strip. Okay, I had a small thin paper strip. If I bend that particular paper strip some amount, like by some amount, the sensor is the flex sensor is like that paper strip only. If we bend that particular sensor to a certain amount, it will give the value like how much the tension between the sensor it is, like how much the amount of deflection or bending amount. Are you able to understand? Hello, Jay? Okay. Huh. Okay. See, Jay. Basically, assume just a paper strip. Okay, a thin paper strip. Like if you bend the paper strip to the downside, you are going to apply some tension on it. Okay, so this sensor allows us to identify like how much tension we are applying to that particular strip to bend, like how much tension we are applying to bend those particular strip, like how much tension or how much bending is happening there, like how much amount of bending is there. Okay, I will also explain this later also. Let's get back to this topic. So yeah, Arduino IDE is an open source software which is used to write and upload code to the Arduino boards. So there are commonly Arduino boards like Arduino Uno, Nano, and Mega, which are commonly used to interface with the sensor. So this IDE application is suitable for different operating systems such as Windows, Mac OS, and Linux. And yeah, it supports the programming language such as C language, C++, and we used embedded C language for Arduino programming. Then in the program or code written in the Arduino IDE is often called as sketching. So whatever we write in this Arduino IDE is known as sketching. So then yeah, and as you know, like the extensions, if we write a Python code, the extension will be dot py. Then and here the extension is saved. The file Arduino code file is saved with the extension of dot .ino. So these are the different Arduino boards such as Arduino Uno, Arduino Nano, and Arduino Mega, and there are also few others. Yeah. So this is the Arduino IDE interface. Here you can see uh, in the text editor section, you will write the code inside it. There is a toolbar option given above. So as you are able to see the right mark on the, like, which is labeled as the verify button. So this button is used to verify your code, like if there are some errors or not. So it is more likely to compiling your code. So if there is an error in your code, it will tell you like the code is written properly or not, or if there is an error, then what is the error is, it will tell you. Then beside that, you can see the upload button. So this button is used to upload your code to the microcontroller, which is Arduino Uno or Nano, whatever you are using. Then there is a button like showing new, which is used to create a new tab or new file. Then you can also open new files from here, and also say there's a button to save that particular file. And beside that, you can see a option of serial monitor. So what is serial monitor? Serial monitor is like an output display. Like whatever, if I write a code to print something, uh, like if I'm writing code to print hello world, so you are able to see that particular hello world in the serial monitor. The serial monitor is like an output display. So so uh, so are you able to understand what is like how this Arduino ID works? So basically, you have to write. Firstly, you have to write the your code inside the text editor section, which is this. After that, you have to verify this code, particular code, and if that code is compiled properly, you're able to upload that code to your respective boards. Am I clear? Hello. Please, if you have any doubts, please ask. Okay. So yeah, today we are going to perform some experiments on Tinkercad. So let me introduce like what is Tinkercad. So Tinkercad Circuit is a free online platform which is developed by Autodesk. So with the use of this software, we can design, simulate, and prototype uh, some circuits by interfacing some components to the Arduino boards in a virtual environment. So it is an tool which is used by beginners and educators. So and yeah, in this with the use of this software, we don't need any physical components. We can just simulate this sensors with the Arduino board virtually. So today we are going to perform three experiments. First is interfacing of LED with Arduino, then interfacing of motor with Arduino, and interfacing of LCD with Arduino. So for this, we are going to use the Arduino Uno board, which is a common board. So this is the Autodesk Tinkercad. So the first task we are going to perform, the first task we are going to perform is interfacing of LED with Arduino board. First, we click on the create button. Here you can see there are three options. First is 3D design, second is circuit, and third is code blocks. Right now we are going to use circuit only. Once you click on the circuit, this type of window shows up. Yeah. So first we select our components. So for the interfacing of LED with Arduino Uno board, we will require an microcontroller, which is Arduino Uno. So I will just search for Arduino Uno. Yeah, and just click and drag it in the screen. Okay. Then we required an LED. And a resistor. Okay. So as our components are selected, we need to connect this component with the microcontroller. For that, we will use wires. So as you can see here, if you click here, you're able to choose which kind of wire you have used. For in our case, we are going to use the normal wire, and yeah. So as you can see, the LED has two terminals. First one is anode and second one is cathode. Basically, the anode one is positive one terminal and the cathode is negative terminal. So I'm going to connect anode terminal to the resistor and then connecting the another end of resistor to 5 volt of the microcontroller. Basically, I'm connecting positive terminal of the LED to 5 volts of the Arduino board. And can anyone tell me like where should I connect the cathode to the Arduino board? It's a simple question. Yeah, to complete the circuit, where should I connect the cathode terminal to the Arduino Uno? Correct, to the ground. So let's connect the another point to the ground. Once the connections are done, here you can see the start simulation option. So if you press the start simulation, the simulation start and the lights start glowing. Okay, but what if I want to control the LED? So are there any options which can be used to control the LED? Any suggestions? How can I control this particular LED? There are several ways to control the LED. Okay, so in your home, how do you control the tube light or another other light? Yeah, switch. So we are also going to use a switch. So we will search for a push button. So we will select a push button. So we'll remove this. Yeah. So this is the push button. In this push button, the terminal 1B and terminal 1A are connected by default, and terminal 2B and terminal 2A are connected by default. So we are going to connect the one terminal of resistor to the terminal 1B, and we are going to connect the terminal 2A to 5 volt. Okay. I'll once again start the simulation. So currently the LED is not glowing, but when I push the button, the LED starts glowing. So basically what is happening here? Initially, the terminal 1 and terminal 1A and terminal 1B are interconnected, and terminal 2B and terminal 2 are interconnected. But when I push the button, the terminal 1B and terminal 2A got connected with each other. So whenever I push the button, the current starts flowing through the circuit, then the circuit is completed, and this LED starts glowing. Is it clear? Hello? Okay. Also, there is one another way to control the particular LED. I'll just So there is also another way which is used to control the particular LED using the particular code. So I will connect the uh, anode terminal to one of the digital pins. So for now, I'm connecting the anode terminal to the digital pin 5 and the another terminal to the ground as well. So here you can see there is a code section. So if I click here and change this to the text, you can see there is a code given for LED LED glowing. Here I will just define my built-in LED pin number. Okay. Yeah. Just click my okay. Hmm. So here I'm defining the pin number to 5. Okay. So as you can see in the code, like I have defined the my LED pin to the digital 5. Like I have told the microcontroller that my LED anode is connected to the digital 5 pin. Then in the void setup, I have told the microcontroller that the LED pin should act as the output device, should act as the output sensor. Then after that, I have run a loop where I'm going to turn on the LED for 1 second, then going to turn off it for 1 second, and the loop will continue. Like the loop will continues. Okay. So this is the basic code. You can also. So if I change this delay to, let's say, 2 seconds, and start the simulation, you can see the LED will start glowing after every 2 seconds and turn off after every 2 seconds. So, so there are basically two ways to control an LED. Like you can either use the VCC or ground option by using switch, or you can use a small code to control the LED. Am I clear? Are you able to understand? Okay. Yeah. Now let's say if I want some other sensor uh, other than this LED, I will just remove this LED first. Okay. Let's say motor. Let's say a motor. We will do a similar connections to the motor. Like the one end should be connected to the ground and another will be connected to the VCC. And if I start the simulation, one second. This we will use a battery. As you can see, this 9 volt battery is sufficient to rotate this motor. But if I say like I want to interface this motor with the Arduino ID, we're not going to able to do that particular thing because Arduino ID will give us the output of only 5 volts, max to max 5 volts. But to run this particular motor, we will require a 9 volt battery. So we can do one thing, like we can make a system like we can make a system where if we give an output by the we can give an input by the microcontroller to the battery. Once just find some other motor which will be able to run that in that particular power. Okay, the motor starts working, but I don't think so. You are being able to see that particular motor. As you can see, it is showing on. So let's create a small circuit to turn on the existing motor. For this, we will require a motor. Then we will require a transistor, which will act as a the switch in in a circuit, and we'll require a battery, 9 volt battery. Okay. So what we are going to do is we are going to directly connect the negative terminal to the negative terminal of the battery. Then we are going to connect one terminal of the motor to the collector side of the transistor. I'm going to connect the emitter side to the positive side of the battery. And connect the base side to the D5 pin, digital 5 pin. Yeah. I'm going to run this same code by just increasing the delay. Let's say for a 20-second delay. So if I start this, let's say 5 seconds. I think that issue with this. Okay, let's skip this experiment for now. There's some glitch with this. Like it is showing the motors turned on, but it's not rotating. Let's skip to the next experiment. We're going to interface the Arduino ID with an LCD. So I've already connected this. Yeah. For this experiment, we are going to use an Arduino board, then an LCD, and one potentiometer. So here you can see I have connected the VCC and ground commonly to the potentiometer and to the LCD board. Then we are connecting some digital pins to the defined uh, digital to define digital pins to the Arduino board. We have defined the pins here. So if I start the simulation, so here in this code, I have counting the numbers. As you can see, the text I have written here, it's been printed here in the LCD. Let's say if I change this text to something else, like hello, hello, God. Start the simulation. Yes, there is some network issue. It is printing hello kite. So let's see the separate pins. So in the LCD, the first two pins are for power, like ground and VCC. Then the V0 pin is used for the contrast, like we can control the contrast of display using the potentiometer. Then we're using the RS pin to select the registers where the where we are storing this particular data in the LCD. Then we're using the enable to uh, enable the display and the digital pins to display our message to send the data. So here's the functioning of the LCD with microcontroller Uno board. Yeah, this is all for today. If you guys having any doubt, please feel free to ask. Hello. Hello. Any questions? No one has any questions. I know you're not going to learn directly from this. Like unless you start doing these things by yourself, you're not going to learn these things. So I hope you will try to do that particular stuff in Tinkercad by today itself, to try to interface this LCD or other some other sensor which are available in this particular site. Okay. So yes, sir, this is all from my side for today. Thank you everyone for listening.